Hello and welcome. My name is Gerhard Zwolber and I'm a data scientist and book author at SAS. In my webinar series, where I show data science use cases and data science in action, we take a look today on how you can simulate the Monopoly board game. Already in primary school, I loved to play Monopoly, or more precisely DKD, which is the version that we usually play here in Austria. And at that time, I already loved to play around with the dice, with the numbers, to count the money. So it is not really surprising that in my career as data scientist and using analytics software from SAS, I tried to simulate and provide an environment where I can make conclusions about the visit frequency and other relationships in this analysis. The data science case study that I'm presenting here today, the simulating complex systems case study, is one out of many data science use cases that I'm presenting here in this webinar series. So we already spoke on Monte Carlo simulations for the sales manager's problem. We spoke on unsupervised machine learning methods to let your data talk. We spoke about survival analysis for employee retention and many other examples. Let's have a look on what we can do with analytics and data science to simulate the Monopoly board game. So today we are going to take a look on how we can study complex systems, for example the Monopoly board game, which definitely is one, and how we can get insight into the most frequent processes, into relationships, and a couple of others. So I'm going to start and give a very brief overview of what Monte Carlo simulations are. And then I go and show you some results and some analysis that I performed based on the Monopoly board game. Applications of Monte Carlo simulations are can be very widely found. It is very often used in cases where problems are that complex that they cannot be solved analytically or mathematically, where it's easier to simulate them. They are also used where it's theoretically possible to solve the problem. However, it's so complex that it's easier just to simulate a certain number of times and then draw conclusions based on the outcome distribution. Monte Carlo simulations are also used to illustrate and understand complex processes and, for example, also to analyze game and investment strategies and many other analysis topics. If we take a look on the applications by industry, we see, for example, Monte Carlo simulation being used to study the loss distribution or the claim events or claim amount distributions in the financial services industry. They are also used to analyze investment strategies and the outcome, what happens if a certain proportion of people perform a certain action. They are also used in production and in manufacturing to detect and to understand, for example, bottlenecks in manufacturing plants and supply chains. They are used to simulate customer networks in communication industries and the reaction of customers on certain changes, on certain relationships when interacting with each other. They are used for many other examples like voting patterns, weather simulations, and many more. When we take a look on the Monopoly board game, we very easily find out that this is also a complex system. We have a set of complex rules, what you have to do, what you should do, how you interact, what is the sequence of actions that you should perform. And there's a framework of opportunities and events, which is the board itself, where you have to use your token and visit certain fields and then follow the actions and have the chance to perform certain actions. There are also additional instructions which come up with a certain probability if you visit a field, depending on the card which is on the top of the stack. And there's of course also a random component. You roll the dice. In my example, I'm using a special edition of the Monopoly board game, the Monopoly Deluxe edition, which not only has 40 but 52 fields and also uses a third dice, which is the Monopoly Man dice, and which introduces a dynamic component into the game. I will explain you more details on this later on. And of course, there's also a monetary dimension where you have investment decisions. You can buy properties, you can buy houses, you have to pay money to other players, you have to pay money to the bank, you earn money, and so on. So we see that this is quite a complex system. So even if we study the instructions and the set of rules very precisely, it would be hard to find out what is the visit frequency on certain fields, what is the expected outcome distribution for certain fields or for certain player decisions. So the best way is to simulate this. The questions of interest that I simulated in my example is to find out what is the distribution of visits of the fields on the board games. Is this very evenly distributed, which you might assume, or is there a certain pattern, is there a certain accumulation of visit frequency on certain fields? How does this look like? Then we will also go in more detail and would like to study which fields are most profitable. Are there certain fields which might have a higher initial price, but in the long term might be more profitable? And what are the influential factors whether a field is profitable or not? And also we would like to study which fields do have quite high variability in profitability. It might be the case that some fields have a high profitability, however there's also a lot of variation, so you might gain a lot of money, but you also might lose a lot of money. This is what we would like to analyze and to study here. Even if this is only the Monopoly board game, the questions and the types of analysis can be easily transferred to many other simulation case studies of financial systems, of complex systems, and of many others. Let's start with the first analysis question, locating the token. So you see I have here Monopoly board game, as I already mentioned, not only with 40 fields, but with 52 fields. And you all know we start here at the start place. And after rolling the dice, we move around and locate our token based on where we end up. And let's now find out what are the influential factors where we end up. Of course, it's the result of the dice that we are rolling. So it is the result, a sum of two dice, which locates our token. There are also instructions on the Monopoly board game. For example, as you see, there is the field go to jail, which relocates your token from a certain field to another field. There are also event fields where you pick up a card, which sometimes tells you that you have to relocate your token certain number of fields forward or backward, or to explicitly visit a certain field. And as I already mentioned in my example, there's also the accelerator dice, which also sometimes relocates your token based on a certain setup. Let's now take a look on if we simulate, if we perform different simulation case studies where we introduce more and more influential factors, how this has an effect on the visit frequency on the Monopoly board game. Before we do this, let's take a quick look on what is the distribution if we use the result of two dice. As we know in Monopoly, we roll two dice and then we sum it up. And obviously the distribution is not evenly distributed, but is a triangle distribution, because in order to come up with the result 7, we have a lot of possibilities to do so. It would be 1 and 6, 2 and 5, 3 and 4, and so on. So this contains much more possibilities to come up with a result of 7 compared to come up as a result of 3, where you only have 1, 2 and 2, 1. So the fact that the outcome of when rolling two dice is not evenly distributed, but triangle distributed, will be mirrored in many of our simulations, as you see it in a second. Okay, let's start with the first simulation. If we only roll the dice only and circulate around the field, we might see the following distribution. We see that it is almost evenly distributed. However, it is not fully evenly distributed, which would indicate here this horizontal reference line, but as we know, we started the game at field number 1, and as all players start from here, we see that here there's the first effect of, as we to a certain amounts at the beginning of a game start from field number 1, we see that we have a small a peak here at fields 7, 8, 9, 10. So immediately starting from field number 1, reflecting this triangle distribution which you already saw earlier. However, then it goes further quite flat, and we see that this is a distribution if we just roll the dice. However, we know that there are certain instructions on the field, and let's now take a look how this looks like when we consider them. This is the result when we also observe the go to jail directive on the field. So this means that all visits to field number 40 are relocated to field number 14. This means if you end up with a token right here in this field, you're relocated to field number 14. This means that here we end up with a visit frequency of 0 because you're relocated from there, and the visit frequency on field number 14 almost doubles because it achieves much more visits, because also the visits from field number 40 end up here. So we see this not only has the effect that this is 0 and this is almost twice as high, this also has the effect that after having more starts here from field 14, we see here a second picture of the triangle distribution. As we more often start here, this also means that the fields around 5, 6, 7, 8, 9 fields away from this field get more traffic, get more visits, because the token more often starts from here. Consequently, we see a decline after the zero gap of field number 40, because there are visits missing that would start from here and jump on these fields. As they are relocated to field number 14, we see that we lose here a certain visit amount. So this is just by observing one condition which is on the field, we already see that this is quite an effect on our distribution on the field. However, there is more, as we see in the next example. There are also event fields. So we see if we pick them, if we pick a card up, it sometimes tells you, for example, on field number 10, we might have to pick up an event card which tells us relocate a token to a certain field. Similar to what we've seen before, this has the effect that certain fields, here, this field, here, and here, they have a lower visit frequency, because if we end up there, we pick up the card, and with a certain probability, we are relocated to a different field. And in contrary, other fields, for example, field number 1, the field you see here, and many others, have a higher visit frequency because you're more often relocated there. So just as an effect of using two dice, using the go to jail directive and observing the event fields, we are far away from an even distribution. And yes, good mathematicians could calculate this also just using Markov chains. However, for me it was much easier to simulate this using a SAS data step and a Monte Carlo simulation to come up with this result. Step further, and also introduce the accelerator dice. The accelerator dice, as you see, if we observe also this one, we see immediately that we are far away from an even distribution. We see that we have a very high variability in visit frequencies. We see some fields are quite low. Now, these are obviously those where you pick up the cards. However, some fields are extremely high in their visit frequency, and it looks like that the accelerator dice has a very high effect on the location of the token. Let's take a look why this is the case. So what is the instruction if on the third dice, on the monopoly dice, the monopoly man is shown? It says, in that case, move your token forward to the next free property field. So you know there are property fields like certain streets which you can buy, and if your token is located on a non-property field, you should relocate your token to the next free field. This has an accelerator effect because now your tokens more often visit free property fields, which you have the chance to buy them or to include them in your portfolio. So this accelerates the effect that you more often have the chance to buy a property. However, it also has the effect that a relocation takes place more often. So let's take a look at that. So for example, if you end up, for example, on that field, on the bus or on this field, and you have the monopoly man, you should forward your token to the next free property. And if all properties are already sold, if all of them are sold, just move it to the next property. This means if the game took place for a certain time, maybe all properties are already sold, and every time the monopoly man shows up and you end up on a non-property field, you get relocated to the next property, to the next field where you could build houses and so on. This has the effect that, for example, fields like those, which are non-property fields, have a lower visit frequency because you are very often moved away from there, compared to fields like this one, which have a very high visit frequency where you very often end up. So introducing the monopoly man during the game means that certain fields lose their visit frequency, whereas others increase their visit frequency. And you can also imagine that, as this rule says, as long as other fields are available, move it to the next free one. If it's not, just move it to the next one. It has an effect during the game. So you see the effect of the accelerator dice after 20 rounds looks like this. Yes, there is some variability. However, if you look at the effect of the accelerator dice after 70 rounds, this looks much different. So we see after 70 rounds we have a much higher variability because in that case, every time a monopoly man comes up, we are moved to the next free field. This means that certain properties gain a very high visit frequency, others gain a very low visit frequency. These are the results of a Monte Carlo simulation for the monopoly game when it comes to the visit frequency, which is very interesting as you find out that it's far away from an even distribution, and this might also influence your buying decisions, which properties you want to buy, obviously those which have a high visit frequency, because other players might have to visit this property more often and you get more payments from the others for them. And I also mentioned that this is a dynamic component as the effect of the accelerator dice changes during the game, so it is dynamic and can therefore much better be analyzed with a Monte Carlo simulation. Let's now also take a look on the profitability distribution. The profitability distribution that I'm using here is based on certain assumptions, because we all know that the Monopoly board game has very complex rules, and in order to make my simulation a little bit easier, I defined a list of assumptions where I said if players are out of stock, they're allowed to take a credit. The base decision is that they always are going to buy, and they will always get money from the others if they're visited on the properties. So just to have some base assumptions. If we now take a look on the profitability distribution of all the fields in my Monopoly board game after 40 rounds, So we see that the distribution of the balance, represented here by box plots, looks like the following. There are certain properties which are not far away from the zero balance. There are more expensive properties where you have to pay more your money when you buy them. However, you also gain more money when other players visit them, which have a higher variability. But you also find out that on average, after 40 rounds, you're very often still in the negative area. So it also has an effect how long the game is played. So if it only is being played for 40 rounds, this might be not enough to repay the investment for certain properties, and this only changes if you play long enough. Long enough might mean, for example, playing 70 rounds or more rounds. In that case, you see that now the distribution changes. Certain fields with a higher visit frequency definitely move into the positive area, some of them quite tremendously, and show that some of them are very positive in their expected balance. Others are still close to zero. Others have a very narrow distribution. Others have a very wide distribution. So this is also a very important outcome, which you can study by running Monte Carlo simulations, where you also have to consider the probability distribution. So we find out that Monte Carlo simulations allowed us not only to study the visit frequency, but also the profitability distribution. And very important, we also see that this reflects both the visit frequency, how often is a field visited. It also has an effect on its profitability distribution, beside other factors like costs and income values defined with the field. Let's now take a brief look on how you can also visualize the results of the Monopoly board game, which were created by my students from Business School of Burgenland, where I'm teaching data science and visual analytics. And they had the task to study the Monopoly board game, or more precisely the DKD board game, the Austrian version of it, and to come up with suggestions how you can visualize this in SAS Visual Analytics. I would like to show you 3 selected examples out of that and explain you what can be seen here and what additional features they were highlighting. The first one that we are seeing here is the display of the visit frequency. So you again see the position of the fields on the horizontal axis, and what they did is they added certain buttons where you can turn off and turn on certain scenarios. So you see, if you turn off the fact going to jail, we see a very similar distribution from what we've seen before. Yes, there's still a peak with the jail, because they considered also when you roll 2 identical numbers on the dice. So this is a very easy one where you can turn this off and on and display different scenarios here in the bar chart. What they also did very nicely is that they fixed the y-axis, because if you run scenarios, it's important that not the entire histogram jumps up and down, but you have a fixed axis which allows you to visually compare the outcome of different scenarios. So different to what I showed you earlier on different static examples, they built with SAS Visual Analytics a very simple dashboard where they have parameters like what is the number of players, how many dice are used, do you consider go to jail, do you consider the event cards, and then display the distribution here as a histogram. Very nicely done. Let's take here a look on another example. This is where they study over the rounds of the game. So here in this example, they consider 120 rounds. What is the profitability of all the fields? So they draw here 1 line per field. So for example, if we select here, for example, field number 4, we see that field number 4, at the first rounds you have a negative balance because you pay for it, and only over time you get visits and come up to the positive area. This is different for field number 15, which is a very expensive property. You get deeper into the negative area, however you get higher up in the positive area, so there is more risk attached with property number 15 because you have to recapitalize the risk. What you can also do very nicely here, for example, they consider what happens if we only consider scenarios we are allowed to build up to 2 houses, or what happens if you're allowed to build up to 5 houses. So you see immediately how important it is if you buy properties that you are allowed to buy houses, because if you're not allowed to buy them, you see that you have very flat lines, and some properties behave better in that case. However, if you have the chance to buy houses, if you agree this with the other players, this has a certain effect on when does a certain property go into the positive area and when not. And you see that this has an immediate effect on the decisions you are making when you are playing this game. As you could see here, how the graphs change if we change parameters, for example, like what is the allowed setup? Are we not allowed to pay to build houses? This would be 0 only, as we saw earlier. Or are you allowed to build 1 to 4 up to 5 houses or a hotel? Again, a very good example that uses the results of the simulation and visualizes them interactively, and give us the chance to review certain outcomes of simulations. Let's finally take a look on the course of the balance per player. So player 1 is the player who starts, player 2 is the second one, player 5 is those who comes at the end. You will see here that player number 1 has a lower balance at the beginning of the place because he has more chances to buy properties, so he spends more money at the beginning. However, then over time he moves up quicker to the positive one because he owns more properties, and the other players have visiting his properties more often and pay him more money. So you can see this here from the graph. This is different for player number 5. He has more money at the beginning because he has not as many chances to buy something. However, over time, he more and more often has to visit the fields of the others, and the yellow line you see, it stayed down very quickly. So you also see that it makes quite a difference on how many players are playing, because if more players are playing, your investment strategies might be more positive, because the others have much more often the chance or the risk to visit your properties and have to pay money to you. So this is also something which needs to be considered when you run that. Again, what we've seen here is that we fixed the horizontal axis, and in order to be able to run these comparison scenarios on a fixed graph and just see the difference from the lines and not have to observe the change of the y-axis. So next time you play the game, be aware that the rule "the youngest player starts" might not be irrelevant to the probability that who is going to win, but the first player really more often has the chance to end up with a better balance at the end compared to the player who started at the end, because he will very often find already bought properties, and instead of having the chance to buy it, he has to pay money there. Again, very nicely done from my students, and how they presented here a dashboard in SAS Visual Analytics. Let's also take a quick look on how I implemented this Monte Carlo simulation for the Monopoly board game in SAS. As you see here, the implementation in SAS has been a concatenation of certain loops. So I looped over the scenarios, the games, I looked over the rounds and players, and I performed then all the actions like generating the random numbers, following the instructions, generate the behavior that the players have, update the counts and the values, and then loop over all these scenarios. So in SAS, I used a data step where I use do loops to loop over games, rounds, and players. Then I used functions to roll the dice or to perform certain actions and also to implement certain decisions. So this is just a very simple example on how such a simulation looked like. And then I used SAS data management procedures to arrange the data for analysis and plotted them or analyzed them. Maybe to come up with a few tips and tricks in coding, what I did is I used arrays in a data step. This is a very powerful way of saving you a lot of programming work and making your code much easier to read. So I defined arrays, for example, like what is the position of a player with the index 2, which says this is the position of the player number 2. And if we say, for example, the player expense of a certain player is an array where I store all the expenses that a certain player has already paid during the game. And you can also concatenate them, like, for example, what is the field revenue where which is where currently a certain player is sitting with a certain player sequence. So these are all all ways which you can very effectively do and use if you use arrays in a SAS data step for Monte Carlo simulations. I also used a SAS format as a lookup table. So, for example, for all the fields, you have the numbers. What do you have to pay if you purchase the field? What have the other players pay you if you own it? So I used a proc format to store this information as lookup tables, which is then very easy to use it in calculations, where you just use this where you say, I would like to use here now what is the cost of a certain field where the player is currently sitting. So I'm using the format and the arrays in one statement, which is a very powerful way to generate the SAS code. And also moving the token is something where I used random number functions, like, for example, the uniform distribution to simulate the dice. Then I added up the dice where I said, okay, if the third dice shows a number, then the dice sum is the sum of the 3 dice. Otherwise, it's just the sum of the 2 dice. And here you see that after the dice were rolled, I'm just increasing the position of the player by the sum which has been rolled with the dice. And I also make sure that after my players visit the field number 52, there is no field number 53, I have to restart with 1. This is also which I did here with a very simple explanation. So this is how I programmed this in SAS, and more on these topics, how I implemented this, you can download the code of all the Monte Carlo simulations from my book on GitHub. You find the link in the comments to this YouTube video, and I'm also planning to create a SAS communities article with more details on how to perform Monte Carlo simulations for the Monopoly board game using SAS. We are now coming to the summary of my case study. So you have seen that I used the Monopoly board game as an illustration for how you can study complex processes and how important it is to use Monte Carlo simulations to get more insight here. And you also can imagine that there are lots of analogies with the real business life. So, for example, in the case when decisions about investments need to be made or not, and you would like to study what is the outcome distribution. Is it extremely narrow or is it very wide? Is it more in the positive or in the negative area? It's also very important that you do not only want to gain information about the expected value, so where it is on average, but you would like to study the distribution, how are the outcome values distributed. And we also saw in this example with the Monopoly Man, with the accelerator dice, that certain strategies and decisions can change in the course of the game, because the accelerator dice change dynamically the setup of the game, and also strategies and decisions can be very different if you know in advance how long are we going to play, will we have the chance to get the money back that we invest in certain properties, or also how many players are playing, because if more are playing, more others have the chance that they visit our properties. This is what I wanted to show you here with the Monopoly board game, and I performed all these simulations in SAS Wire, which offers a very powerful setup to study and to visualize Monte Carlo simulations. So you have a very powerful set of functions and expressions to run them in DataStep or in DS2, or also with a matrix language. You have analytic procedures to calculate all these analytical values, and you saw graphs and how my students used such visual analytics to create interactive visualization dashboards. In this webinar series on data science case studies, you saw that analytics and data science is here to help you. You gain a clearer and more objective picture of your data. Even after I played Monopoly and the Austrian version very often, I was not aware of all these relationships in that detail. So Monopoly simulations allowed me to present these results to me, to understand them, and to take a look and to make these processes or the data here talk to me and get the results very explicitly. So this is what I wanted to present here. And another case study that I took out of my Applying Data Science book. And if you're interested in more content, you see in this YouTube playlist many more recordings of my data science webinar or on contributions that I made on social media and on SAS communities. It has been a pleasure to present this for you, and I thank you very much. Danke.